Fine. Okay. So here's 3 slides at 1 minute each, and they're covering 3 areas: international, national, and local. And then in the area of high performance big data computing, which Fred Kate just mentioned. And these collaborators involve Fudan, which we just heard about. And then I have a project funded by NSF, which involves NIST, Intel, and 6 different universities. And then there is, I will mention the BDEC-NG, which is a very large international collaboration involving Europe, China, Japan, DOE, NSF, and our friends at Tennessee and Northwestern and other universities. And locally, I work with Judy, Martin, and David, plus the Precision Health and Hewitts. And all right, so actually this is sort of largely my research. And so this project involves 7 universities, and it's now almost 5 years old since we actually proposed it. It involves an application-driven development of big data technology, the software to manage the data and to organize it, and the parallel algorithms. Judy will tell you more about that part of it. And so here we work with, David is working as one of the application areas, the remote sensing for polar science with Kansas University, one of our collaborators. One of the parts that I do is called Twister 2, which is effectively a replacement of Spark, Hadoop, and Flink, and Heron, and Storm, which are the major Apache systems here. And it does that by taking the capabilities of those systems, abstracting them into half a dozen different key components, such as data flow communication, bulk synchronous communication, task management, fault tolerance, and data flow. And then we put in the best available approach, which is actually available, usually in open source for each of those components. And when you do measurements, you will, I wouldn't show you if it wasn't true, but if it wasn't, that we always outperform Heron or Spark or Flink when we test particular applications, because we are able to put together the customized solution. All right. Our second slide is even Vega. This is it's now in its 5th year, BDEC, which stands roughly for Big Data Exascale. And it corresponds to taking the exascale activities, which are billions of dollars around the world in China, Europe, Japan, and the US, where Europe is actually very, very active here. And we're trying to put together bring together those communities, link them to other communities, and see how exascale computing systems relate to big data. There's a whole set of meetings. We've had probably half a dozen already. This is BDEC-NG, the next generation of BDEC, which is meant to move faster than the previous one. And it is going to last 2 years. And the first meeting here, which is going to be organized by Judy, is going to be in October on Bloomington campus. And so that could be pretty interesting, because when you host it, you're allowed to bring your own people to the meeting. Otherwise, it's all by invitation only. And my last slide is as a start of the work with Fudan. We organized this meeting on high performance systems for data analytics. And then we had these quite impressive collection of speakers. And listed here, notice it starts with, we were pleased to have Rick Van Kooten gave us the opening, and we were strongly supported by both the school and OVPR. But we had pretty interesting talks by IBM, Intel, NIST, and Department of Energy, which is of course very active in this area. They probably have in the US the most resources in this area, plus many of the academics who I think are working at leading edge. So we will publish a report on that meeting, and that's it. Thank you.